Hey there, Keys Pre-Calculus. I am going over an example in section 9.2. We are doing analytical geometry, and this section covers ellipses. As we learned in class, we learned the standard equation of an ellipse with the center at HK. HK could be the origin, 0, 0, or it could be anything off the origin. Its center, we're going to just call it HK, with a major axis of twice the distance between the center and a major vertex, and then there also has a minor axis, which is twice the distance between the center and a minor vertex. The major axis is always going to be the longer one on the ellipse. So in a horizontal ellipse, that means the major axis is parallel to the x-axis, and the vertical ellipse is always going to have a major axis that's parallel to the y-axis. All of this is on the cheat sheet I gave you. I also wrote it up in here. I put a little color in there so you could see where everything is. You can take a moment, pause your video, and study this if you need to before we move on to the next, or before we move on to the example, because I'm going to take it off the screen in a second. Example 4 on page 642 gives you an equation of an ellipse, and it says to find the center, vertices, and foci. And of course, it probably wouldn't hurt to sketch it either. But what we have to do is we have to take this equation, 4x squared plus y squared minus 8x plus 4y minus 8, and put it into one of the standard ellipse equation forms. In other words, we need to either make it look like this horizontal ellipse or this vertical ellipse, and we will find out which one it will be when we work with the equation. Now, coming back to the equation, we see that it's not in standard form, obviously. We need to do something to this equation to put it in that form. And that something is completing the square. So the first thing I'm going to do is I'm going to collect my x's together, collect my y's together, and move my constants to the right side of the equation. So I'm going to collect my x's, 4x squared minus 8x. And over here, I'm going to say plus y squared plus 4y. And that's going to equal, as I move my negative 8 to the other side, 8. In order to complete the square, I need to have a leading coefficient of 1 for each square that I'm completing. So here, my leading coefficient is 4. I need to get rid of it, and the easiest way to get rid of it is to divide everything by 4. But if I do that, then that would make my leading coefficient of my y terms not be 1 anymore. So I'm just going to divide it out of my red terms right here, my x terms. I'm going to divide out of 4, and I'm going to be left with x squared minus 2x. And it's not really going anywhere. It's just changing positions here, because I'm not taking it away completely. But I'm also going to add something to complete the square, and I don't know what it is. And when I do it that way, I leave my y term free to keep its leading coefficient as 1. So now, or not my y term, but my y terms, sorry. Now I'm left with y squared plus 4y plus something. I don't know what it is, but it's got to be something to complete the square. And then that's going to equal 8 plus the red something plus the purple something. Okay? So now let's see, let me figure out what it is that I have to complete the square with, or what terms I use, what numbers I use to complete the square. Remember, we always take the b term, and we half it, and then square it. Well, half of negative 2 is 1, is negative 1 actually, and negative 1 squared is positive 1. So I think it seems like I'm adding a 1 here, and so I would add a 1 over here, except I'm not. I'm adding a 4 times 1. So I'm really adding a 4 to both sides when I do the red, or the x's. Now I'm going to do the y's, which is purple. I look at the b term here. Half of 4 is 2, and 2 squared is 4. So I'm adding a 4 to this side. I'm going to add the same 4 to that side. So do y'all see how we've done that? Now I'm going to factor these. So I'm going to factor out of my red here or not factor out, I'm going to factor my trinomial, which becomes x minus 1 squared. And then I'll factor the y trinomial, which becomes y, and I guess I could put parentheses around here so y'all can see that. That becomes y plus 2 squared. And then when I simplify the right side, I get 8 plus 4 is 16. Now this is not quite in the form I need it to be in yet. If you will notice, in both equations, both for the horizontal ellipse and the vertical ellipse, my right side is 1. And my left side is divided by, or has denominators of my a squared, which relates to the major axis, and a b squared, which relates to the minor axis. So I need to do that with my equation. I need to make this bottom equation of 4 times x minus 1 squared plus y plus 2 squared equals 16 look like the standard equation of an ellipse. And the way I'm going to do that is I need to turn my right side into 1. And the way to do that is divide every term, I should say, not just both sides, but every single term in here by 16. So when I do that, these cancel each other out, and this becomes 1. And I can simplify this. 4 goes into itself once, it goes into 16 4 times. So I have x minus 1 squared over 4 plus y plus 2 squared over 16. Now, is this in the standard form that I need? Well, yes, it is. Because even though this says a squared, I don't have to have a number squared here. I can just have the number. But sometimes it's easier if I put it into the a squared form. The same thing with the b squared. I could just have the number 16 like I have it here, or I have it on the equation, or I could rewrite it as 4 squared. And because this was, I think, 4, I can rewrite this as 2 squared. But I don't have to, as long as I understand that when I'm looking for a and b, I have to take the square root of those numbers. Let's show you what I mean. Okay, I rewrote these numbers with colors so y'all could see it a little bit better. But I could rewrite this denominator right here. Instead of being 2 or 4, I could rewrite it as a 2 squared if I wanted to. And I could rewrite this denominator. Let me change the color here. Sorry about that. I could rewrite this denominator right here as a 4 squared if I wanted to. Because that would tell me directly what my a and my b is. I can see that because the denominator of my y term is larger, that's going to be my major axis. So I'm going to have a vertical ellipse. And so if I were to plot the points here, I would say, okay, my center is at the point 1, negative 2. So I'm going to come over 1 and down 2. Let's just over 1, down 1, 2. My center is going to be right here. Now, my major vertex is the my major axis, sorry, is the horizontal, the vertical one, because the larger term is under y. And my a term in this case is not 16, but 4, because 4 squared, because a squared is 16, so a is just 4. So that means that my major axis is going to be twice a. So it's going to be 4 units up from the center going up, 1, so we're going from the negative 2 to negative 1, 0, 1, and 2. And then 4 units going down from negative 2, which would be negative 3, negative 4, negative 5, and negative 6. And it's going to be happening along the major axis, or along the vertical. And then my minor axis is b, which I know that this 2 squared is not real clear right here, but that's 2 squared. So my b, since my b squared is 4, my b term is 2. And so that means for my minor axis, I'm going to be going 2 units from the 1 to the right. So that would be a 2 and a 3. And then 2 units from here would be a 0 and a negative 1. So that would give me my minor axis. And now I can draw my ellipse, which I know the problem did not say to draw the ellipse, but I always find it very helpful to draw what I can. Of course, we all wish we were artists. I'm not. See if I can fix that. So I straightened it up a little bit. Now it does say to find the center, the vertices, and the focus, or the foci of the ellipse. So my center is pretty easy. We can do that from our h and our k, just from our equation. Over here I'm going to write my center is at the point 1, negative 2. And I got that from the h and the k. I don't know if you can see the arrow circling it, but that's in my equation. The h right here, which I'll just, you know what, I'll use my underline, the h and the k. And now I need to find my vertices. Now when it asks for the vertices, it's not really asking for all of them. It's asking for the major vertices. So I know that one of my major vertex is above the center, and one of my minor vertex is below the center in a vertical ellipse. And when I say above and below, a units above, a units below. So my my x value is going to be 1, and then a, or 4 units above negative 2, is positive 2, and then 1, and 4 units below negative 2 is negative 6. So my vertices are at 1, 2, and 1, negative 6. Now what I need to do is find my foci. Looking back at these standard equations and the drawings, you'll see that the foci is c units from the center, either below it or above it, because I'm looking at my vertical ellipse. I don't know if you can see the arrow that I'm circling here, but I'm looking at this bottom ellipse, and I see that my foci are c units above my center and c units below my center. So we got to figure out what c is. What I forgot to put up here when I created this was what you do have on your cheat sheet and what we did learn in class. Don't forget that a squared was equal to b squared plus c squared. My foci, or my focus, comes from c, so I want to isolate that. So I need to remember that c squared is equal to a squared minus b squared. And I can use this information in my equation to find out what c is, because I know what a and b are already. I rewrote that information up here. It is also on your cheat sheet. So all I need to do now is plug in my a and my b and solve for c. So I'm going to do this little scratch work under here, and I'll just say, since my a is 4, so c squared equals 4 squared minus my b squared is 4, so my b is just 2, so it'll be 2 squared. So c squared is equal to 16 minus 4, which is equal to 12. But I don't want to know what c squared is. I want to know what c is, so I have to take the square root of this. So if I take the square root of c squared, I get c. If I take the square root of 12, I get c is equal to both the positive and negative 2 squared root of 3. I forgot to take the positive and negative here. Well, I didn't. It's positive and negative 2 squared root of 3. So my foci are going to be, again, along the major axis. And since it's a vertical ellipse, this time it's going to be parallel to the y-axis or the vertical axis. So it's going to be up from the center point 2 squared root of 3 units, and down from the center point 2 squared root of 3 units. But my x is going to remain the same. So my foci is going to be 1, and then it's going to be negative 2 plus 2 squared root of 3. That's one focus. And then my other focus is going to be 1, negative 2 minus 2 squared root of 3. So those are my foci. So this is how you take an equation, an elliptical equation, and you break it apart into its parts and find a center of the vertices and the foci. And I also added sketching it in there, even though the example didn't tell you to. Other examples do. Now this is the only example I'm going to work. I'm asking you to please study the application problems on page 644 and 645, you will have an application problem for your homework. So I really want you to study. It's interesting reading because it talks about the moon's orbit around the Earth and some other eccentricities. So read those, study the examples. I hope you can figure out the homework from this. It shouldn't be too hard. If you need to, go back and watch this video again and study the cheat sheet I gave you. Y'all have a great weekend. Happy Easter.